A ball is dropped from a height of 3 meters. Each time it hits the ground, it bounces up to 90% of its previous height. How high does it bounce on the fifth bounce? On which bounce does the ball reach maximum height of less than a meter? And assuming the ball keeps bouncing until it rests, find the total distance traveled by the ball. So we assume the ball is being dropped from the platform and it is, it falls down. So this would be 3 meter, and that's the first, it's like count of 0, and then it hits the ground and it bounces up, and this is the first bounce. So I can write here first bounce, and in the first bounce what happens is it rises up to 90% of its previous height. So that means it would be 3 multiplied by 0.9. And then in the second bounce, it again rises up to 90% of the previous height. So that is 0.9 times 0.9 times 3. Okay, so this is the second bounce. So here that's 2. Second bounce. So you see, we can say that use it as a sequence problem. So we can say that n is 1, and for this we have n is 2, and for n is 2 we can write it as 0.9 square times 3. So, and then if you had n is 3, you can write it as 0.9 cube times 3, and so on. So if I write it in a different way, I can say n is n, and if I make a column of say n and another column of the height, so if n is 1, it is 3 times 0.9, and that is 2.7 meters. So the height is in meter. And then if I have n is 2, it will be 3 times 0.9 square, and that is 2.43 meters. And if you have 3, then it would be 3 times 0.9 cube, and that is 2.187, or we can say 2.2. Anyway, I will say 2.19. And then if n is 4, I'd get 3 times 0.9 to the power 4, and that is 1.97. And then if n is 5, which is what we have to work out, that is the fifth bounce. So the fifth bounce would be 3 times 0.9 to the power 5, and that would give you 1.77 meters. So the answer is, on the fifth bounce, it would be 1.77 meters. So the next question is, on which bounce does the ball first reach a maximum height of less than 1 meter? So as you can see, this is a decreasing sequence, so 2.7, 2.43, 2.19. So it's decreasing. So if we continue, it will be less than 1.77. So suppose we do n equals 10, what do we get? So we'd get 3 times 0.9 to the power 10, and that is 0.9 to the power 10 multiplied by 3, and I'd get 1.046. So that would be 1.05 if I do that. And then if I say n equals 11, what happens is 3 times 0.9 to the power 11, and that would give me multiplied by 3, and that is 0.94. So you see, this is when the so that is the first time or the first bounce in which the maximum height is less than a meter. So that is the 11th bounce. So that is the 11th bounce, right? Okay, so that's part B done. So the part C, what it's asking us is to find the total distance traveled by the ball. So obviously in this case what we have to do is, now I don't think I need this anymore. I'm going to erase this bit because this is very much like a geometric series, and I think for this question what we will need to do is to do the sum to infinity, because each time it keeps decreasing the height of the bounce, or the height the ball attains. So to find the total distance, so I can write the total distance equals 3 meter, the first 3, plus 3 times 0.9 plus 3 times 0.9 square. But you see, something is happening here. Before that is, it is 3 plus, each time it bounces there, it covers twice the distance. So it touches the ground, it goes up, again it comes down. So it is twice the distance. So I have to write a 2 here. Okay, plus square. So then I can continue with my sequence. So plus 3 times 0.9 cube, and so on to infinity to the power, because we don't really know how many bounces it will be until when this the value, it becomes 0, or it is, the ball stop bouncing. So this we can write it as sum to infinity in a geometric series. So that would be 3 plus 2 times, we can write it as 3. So we know that S infinity, so sum to infinity is A out of 1 minus R, where A equals first term and R is the common ratio. So in this case, A is 3 times 0.9, or if we keep 3 outside the bracket, we can just say that A is 0.9. And we can say that R is also 0.9. So this can be written as, I can write this as, that equals 3 plus 2 multiplied by 3, and then I can write it as 0.9 divided by 1 minus 0.9, because here R is 0.9 and that is less than 1. So this is what I can write it as, and that would be 3 plus 2 times 3 is 6 multiplied by 0.9 divided by 0.1. That is 3 plus 6 times 9, that is 54. So I get 57 meters. So the total distance traveled by the ball would be equal to 57 meters.